In this video about the conceptual design phase, I'll provide an overview of different strategies that you can apply inside this phase for doing more informed and qualified design decisions in your design process. We'll take a look at different opportunities and applications that you can effectively apply in a holistic green BIM workflow. One of the most important phases in sustainable design development is the phase of conceptual design. In this phase, we can, based on climate analysis and the reference studies that we did in the pre-design, work with creating form and energy models based on our design proposals that we can use for investigating performance and evaluating different design alternatives. So this phase is really looking at optimizing things like daylight and visual comfort, natural ventilation, shading and solar gains, the distribution of internal loads, and beginning to create the foundation for choosing which kind of materials and constructions we want to implement in the project. So here, a great way to start is using the strength of Autodesk Vasari for really being able to create some very conceptual concepts and doing quick and fast evaluation of different design alternatives, looking at things like solar radiation, Ecotech windrows, and other very fast applications or simulations that has been implemented from Ecotech analysis, but is a lot more fast to do inside Autodesk Vasari. And here we can as well use the strength of the conceptual energy analysis, quickly creating predefined energy models with predefined glazing properties and areas, which allows us to investigate the envelopment in relation to glazing radius, in relation to orientation and form, and doing very fast studies and comparisons of different design alternatives, looking at comparing these different design proposals' performance in the conceptual energy analysis. And then we can, at a later stage, bring this model effectively into tools like Ecotech analysis for doing fast evaluation of things like daylighting and internal loads inside the model, looking at monthly load discomfort and passive gains breakdown that are really effective tools for evaluating and identifying problems areas inside our design. And again, here at a later stage, we'll work with creating some very conceptual rooms that we can evaluate for things like daylighting, looking at the visual comfort and quality inside the building or a space, and then use Ecotech in combination with tools like Radiance for doing daylight visualization with the possibility of overlay of numeric data, and then being able to push these things into the design decisions that we make. An important factor working in every phase of sustainable design development is choosing which type of modeling techniques and simulations possibilities you want to implement in your project. So let's go a bit more into details with a good strategy and workflow inside the conceptual phase. Let's start out in Autodesk Vasari. As I showed before, using design options, and because you're limited to work with massing and conceptual geometry within here, you're really restrained to work conceptual, and that's what we're looking for. In this project here from Henning Larsen Architects, we really show the progression, and what we were looking for here were using the solar analysis tool for optimizing the distribution of light and heat coming from the sun, so we'll be able to have a more balanced indoor visual climate, and we'll be able to collect a lot more energy from the sun because we split up this building in more pieces. And in this project here from Juhl and Frost Architects in Denmark, we really used here the capability to evaluate multiple concepts and bring that together in Excel for comparing these different types of analysis. And then from here you really have a great interaction with EcoTech analysis where you can do many of the same simulations. Things like wind simulations has been implemented in Autodesk Vasari and allows us to, on a very conceptual stage, to use climate data from the nearest weather station to evaluating how our design will perform on our exterior spaces, but as well in relation to things like natural ventilation strategies we want to implement. Really, we have a lot of the same functionality, but what EcoTech provides us with is that it's a bit more effective to work with the output. First of all, looking at the grid here, we can choose where there's between 0 and 6 hours of sunlight, and in that way use this great tool as an identifier for many of the simulations that we'll perform. And as well, of course, very simple shadow studies that will help us really go to different sun extremes throughout the year. And again, with inside EcoTech, it's really a great possibility that you can have multiple projects coming in here, and you can just save it out here in the zone management, which helps you to quickly bring in or bring back simulations that you did previously to visualize these in relation to the specific design. One other great example here is this project from Henning Larsen, where we use solar radiation analysis for optimizing the envelopment and creating an understanding of placement of glazing on the model here to have it a bit more open on the north side and to make it a bit more closed where we had a lot of radiation. At a later stage or in the same phase, and here we're working with very conceptual rooms that we can evaluate, primarily looking at daylighting. Daylighting has really a great impact on the comfort, the energy loads, and the quality within inside a space. EcoTech is really only looking at the quantitative amount of daylight. So that's why we're using EcoTech analysis in combination with radiance that allows us to create daylight visualizations with overlay of data and allows us to create overlay of contour lines and create a more visual interpretation, human sensitivity, overlay of false colors that will help us to identify the light levels within inside the model. At the final stage, we can use DaySim in combination with EcoTech for really creating the final validation and lead credentials that we're looking for. Let's take a close look at the conclusions and next steps from this phase here. What we're looking for here is an optimized envelopment and optimized concepts in conceptual rooms that we want to place within inside the envelopment in strategic locations. And we are also looking at collecting all the simulations and data to make validated decisions on which on which design we want to move on with, or which changes we want to implement from the different simulations and design alternatives that we did. For doing this, we need to be able to compare both numeric data and evaluate numeric simulations that we did in this phase. For looking at numeric data, right now I'm really using Excel, looking at the facts of the building, looking at the energy profile, visual comfort, let's bring up the right one here, visual comfort, solar radiation, and other things that we can measure. And again, as well, implementing a design point of view is really critical, because comfort and energy is not the only thing controlling if we have a great building. But being able to bring it in and evaluate and see in a visual graph here what type of performance are performing the best is really essential here.